Hello, my name is Tom Zessiger. I'm an instructor here at APUS, and I'm going to give you a quick overview of ELEN305 Electrical Circuit Analysis. So in ELEN305, we're going to introduce you to the basic circuit elements, which are resistors, capacitors, inductors, and the first thing you'll learn is Ohm's law, which is fundamental law of electrical engineering, and you can use Ohm's law to solve for an important circuit parameters such as voltage, current, and power. You also learn Kirchhoff's law, Thevenin Norton equivalence, and superpositions, very important circuit analysis techniques. Series of parallel circuits, which is the two fundamental arrangements of elements within the circuit, and direct current and alternating current circuits. So that's the two really major types of circuits, and it's basically just introductory stuff in the foundations of electrical engineering, which is circuit analysis. Okay, so the course outcomes, I'm not going to read all these off one by one. So basically, it's all the things I just talked about. Is when the course outcomes, when you're done with this course, you should be able to solve and analyze any circuit that's thrown at you using these techniques and solve for voltages, current, power, any of those things that we just talked about. So how's this relevant to the field? Well, circuits are the foundation of all of electrical engineering, really. Circuits are contained in almost every piece of modern electrical and electronic system. Any type of electrical or electronics boils down to a circuit somewhere, and you can design more complicated, put circuits together to design more complicated systems, such as power systems. An electrical power system, whether it's in your house or the distribution coming into your house, or the entire power grid, you can model that with a circuit. Complex electronic systems such as communications and radar are made up of a series of circuits that perform different functions that the system wants to perform. What you need to know, so ELEN300 Electrical Engineering Fundamentals and ELEN303 Measurements and Instrumentation, that's the prerequisites. There's no other knowledge required. Like I said, it's a introductory course and fundamental EE course. Where you can go next, ELEN307 Digital Circuit Theory, Continuous and Discrete Signals and Systems, ELEN312 Energy Conversion and Processes.